Polynomials, linear factors, multiplicity, graphing, and writing. You'll be able to write a polynomial expression in standard form from the factored form. You can write a polynomial expression in standard form from the zeros. You can identify the multiplicity of zeros, and you can graph a polynomial by hand. And part of that is you will also understand what a multiplicity is. First, polynomials and linear factors. If you're given a polynomial in factored form, x plus 1, x plus 2 times x plus 3, you need the polynomial in standard form, or you're asked for this polynomial in standard form. What do? You multiply. That's all. You multiply. Same thing you've always done. Does it matter which one you do first? Why, heavens no. Remember, we've got the commutative property. We can move the factors all over the place. So multiply two of them together and then multiply the third one. In the end, you'll wind up with the x cubed plus 6x squared plus 11x plus 6. Now, here I have x plus 1 times x plus 1 times x plus 2. Write it in standard form. Pause the video and try this. You're just foiling it. Okay? You're back. Let's see. How did you do? Did you get x cubed plus 4x squared plus 5x plus 2? If I was going to do this, I would do the x plus 1 times x plus 1. That is, I would have x squared plus 2x plus 1, and then I still have it times x plus 2. At this point, you can do a couple of things. You could do x and 2. If you're somebody who struggles with multiplying this out and you tend to get it wrong, especially if you're somebody who you can't really read your own writing, occasionally you get a little sloppy, make a multiplication table. Don't hurt yourself, okay? Now, x times x squared is x cubed. X times 2x is 2x squared. X times 1 is x. 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 1 is 2. Now you go through and you add everything together. I have an x cubed. Don't have any other x cubes. Now I have 2x squared and 2x squared. That gives me 4x squared. Then I have 4x and 1x. That gives me my 5x. And then I just have the lonely little 2. Notice, that's the answer I get. Okay? Now you get the polynomial in standard form and want it in factored form. Well, simply factor the expression and write all the factors. Don't forget to always check first for greatest common factor. Here, the first thing, notice I have 2 will go into 2, 10, and 12. I've got an x cubed, x squared, and x. So my greatest common factor is 2x. Take that out first, and it's a simple problem to factor. Try the next one. Did you pause the video? Good. Hopefully you did, and now you're back. 3x cubed, 3x squared, and 36x. My greatest common factor is going to be 3x. When you do that, you'll get 3x times x squared minus x minus 12. Factors of negative 12 that add up to negative 1, and since a is 1 here, I don't need to make the whole star. I can if I want. This would be negative 4 and 3, and then you can do bottoms up. Okay? Good. Hopefully these are easy. Now, finding the zeros of a polynomial function. Think about how you found those zeros. You set each factor equal to 0. Okay? So, if I have this in factored form and I want to graph it, the first thing I should notice is that I can find every place where it's crossing the x-axis. Okay? So, I can sit here and say it's crossing it at 2, it's crossing it at negative 1, and it's crossing it at negative 3. What else do I know? Well, remember our end behaviors? This is going to be x times x times x is going to be an x cubed. So I know that the degree is going to be 3. Positive times a positive times a positive, the lead coefficient is going to be positive. So my end behavior is going to be down and then up. So from this one, it should be going down. From this one, it should be going up. And then notice I can do this. Now, I didn't put anything along the y-axis because I haven't got any other point, so I don't know how high this relative maximum is or how low this relative minimum is. But I can get the general shape of the graph and where it is on the x-axis. I know when things are positive, when y's are positive, when y's will be negative. Okay? Let's look over here. Zeros can be found by inspecting the graph of the polynomial and noting the x values where they cross the x-axis, also known as the x-intercepts. Here, -3, -1, and 2. This is our graph over here. I actually graphed it. Notice we've got the right shape. Pretty cool, huh? Now, factor theorem. The expression x minus r is a linear factor of a polynomial if and only if the value of r is a 0. Okay, if I want to find the zeros of this function, okay, I'm going to sit here and say, all right, that means x minus 7 is equal to 0, so x equals 7. X minus 5 is equal to 0, so x is equal to 5. X minus 3 is equal to 0, so x is equal to 3. So at 3, 5, and 7, I'm crossing the x-axis. End behavior. Positive, I'm looking at all the x's. Positive times positive times positive. Lead coefficient is positive, and the degree, x times x times x, is 3, or odd. Therefore, my end behavior is down and then up. I just said my zeros are 3, 5, and 7. So after I cross here, it's got to keep going down forever. Why? Because that's on the left-hand side. This is on the right-hand side. It's going up forever because it can't cross back over. Now in between, I've got this going on. Again, notice I don't have a scale over here because I haven't done anything to figure out how high above or how far below the relative maximum and the relative minimum are. Catching on? Good. Well, now what if, instead of giving you a polynomial, I want you to write the polynomial function, and all I'm going to give you is the zeros. I'm going to tell you the zeros are -2, 3, and 3. Huh. Well, you know then that that means that x equals -2. X equals 3, x equals 3. Well, think about it. How did they look before they got to that point? Well, each factor was set to 0. So I need to set this to 0, so I add 2 to this side, I subtract 3. Now, notice I have my factors. X plus 2, x minus 3. I just drop the equals 0, okay, get rid of that part, and now put parentheses around all of these guys, and I have my function in factored form. Great. Well, what happens when you want to write it in standard form? I'm going to multiply them together. So I multiply, in this case, I multiplied these two together. Okay, whoops. And come back. I don't know what happened there. That was weird. Okay, so I guess I multiplied these two together to get the x squared minus 6x plus 9. Now I'm going to use the distributive property, which means I'm going to multiply the x times every term here and the 2 times every term. And this is another way to do it if you don't like the box. And it makes it a little bit easier to see. X times x squared is x cubed, x times minus 6x is negative 6x squared, x times 9 is 9x, plus 2 times x squared is 2x squared, 2 times negative 6x is negative 12x, 2 times 9 is 18. Then you combine your like terms. So here I combined minus 6x squared and 2x squared to get minus 4x squared. 9x and minus 12x to get negative 3x. The x cubed and the 18 didn't have any friends. There, I've gone from the zeros to the factored form to the standard form. And it doesn't take very long. In our previous example there, the value 3 came up twice as a 0. We had x equals 3 and x equals 3. When a linear factor is repeated, the 0 is repeated. A repeated 0 is called a multiple 0. A multiple 0 has a multiplicity equal to the number of times the 0 occurs. In the previous example, 3 has a multiplicity of 2 because 3 happened twice. Why do we even care? How is multiplicity helpful? Oh, it's so helpful. Multiplicity indicates if the 0 is a cross point or a tangent point. Sometimes you will also see the word tangent. Instead of tangent, you'll see turning point or touch point or bounce. I personally like the fact that tangent, touch, and turning all start with T's. Bounce doesn't start with a T, but it also has the same kind of idea. You bounce and go back the way you came. So notice here I've graphed our previous function, and we had a 0 at negative 2 that only happens once, and we had a 0 at 3 that happened twice. I get a 3 here and a 3 here. Since this has a multiplicity of 2, it is tangent or turns or touches or bounces, whatever term you like. So a multiplicity of 1, we cross. A multiplicity of 2, we touch and turn. Now here's the thing. It's not just 1 and 2, it's odds and evens. Okay? Odd multiplicities cross. Even multiplicities touch, turn, tangent, bounce. So, for each problem below, determine the zeros. State the multiplicity of each 0. State if the 0 is a cross point or a tangent point. Determine the end behaviors of the function. Sketch the graph. If you'd like to try these on your own before going through them with me, great. Pause the video now or just keep watching. Okay, so for this one, we know that 0 is equal to x squared plus 4 x squared plus 2. We just factored it. So x squared is equal to 4, or x squared is negative 4, or x squared is equal to negative 2. X is equal to plus or minus 2i. X is equal to plus or minus I root 2. What does that tell you? That tells me I've got issues here. Let's try one other thing. What's something I did not do? Do you see it? What didn't I do? I did not take out my greatest common factor first. 0 is equal to x squared. Then I have x squared plus 6x plus 8. Now 0 is equal to x squared. Now I have x plus 4 times x plus 2. Gotta take out that greatest common factor first. It's important. Now, x equals 0, or x equals negative 4, or x equals negative 2. That means I have 0, negative 4, and negative 2. This one happens twice. Let's see. This one happens once. This one happens once. This is a tangent or touch or bounce. This one is a cross, and this one is a cross. The end behavior, it's even, positive lead coefficient, so I should be having up, up. Okay? This is how to graph it without a calculator. We're going to graph them down here in just a minute. This next one, much nicer, it's already factored. My factors are 2 and -1, and notice it happens once, 2, 3 times. -1 happens 3 times, 2 happens once. They're both odd, so they're both cross points. 1, 2, 3, 4. It's an even, and I've got positive times positive times positive, so this one also is up, up. This last one, I've got a greatest common factor of x, and I've got x squared minus 4x plus 4. I have x times x minus 2 times x minus 2. My zeros are 0 and 2. 0 happens once, 2 happens twice. 0 is a cross, 2 is a tangent, because I'm looking at the multiplicity. Now, this is odd with a positive lead coefficient, so my end behavior is down, up. Now, if I want to graph these, this first one here, I have 0, -4, and -2. So 0, -2, and -4. My end behavior is up, up. But at 0, I have a touch. I don't cross. So I cross at -4, and I cross at -2. I cross at -4, and I cross at -2. This one I bounce. And my end behavior is up, and here it's up. So this must mean I've gone down here, I go up here, and then I've got to come down like this. Again, it's not exact, but you got to take a look at it. Okay? Take a look at it on your calculator. You'll notice it's the same shape. The next one, I'm crossing at 2 and -1. So at 2 and -1 and and they're both crossing. Okay, they're both crossing because they're both an odd number of times, but my end behavior is up, up. So it goes up and it goes up, and down here, whoops, hang on, explain something. At 2 and -1, the greater the multiplicity, the flatter the curve is. So this is going up. And then what happens here is while this is going up, it's going to flatten out when it comes down. So it'll look something like this. Okay. There we go. So you'll have something that looks like that. And then this last one over here. And again, I'm not asking for exactness. I would be looking for end behavior being correct, cross points to be correct. Down here, we said that we've got 0 and 2, where 0 crosses and 2 is touch. So 0 and 2, 0 crosses, 2 is a touch, and it goes down and then up. So I've got my down, and I've got my up. It's going to look something like that. And that's just a quick sketch so that you have the shape of the graph. This would be without a calculator. You would be doing this. Okay? Great. Relative maximums and relative minimums. We've talked about this before. You have an absolute maximum and absolute minimum, but these relative maximum and minimums is when it's a turning point. Turning points are your relative maximums and minimums. And we also discussed using the calculator. It's just written here again in your notes to remind you. In summary, zeros are referred to as solutions, x-intercepts, and roots. You need to know all 4 terms. Zeros of a polynomial can be found by graphing and determining the x-intercepts, or by factoring and using the zero product rule. A polynomial can be written in standard form from its zeros You write a linear factor for each given 0, then multiply them all together. When the linear factor is repeated, the 0 is repeated, and it has a multiplicity. The multiplicity is how many times does that appear. A multiple 0 has a multiplicity equal to whatever. So if you have x plus 3 quantity cubed, then negative 3 has a multiplicity of 3. Multiplicities are important because they tell us if they're cross or tangent points. When the multiplicity is odd, the graph will cross the x-axis at the 0. When the multiplicity is even, the graph will touch the x-axis at the 0 and turn around. The graph is tangent to the x-axis at the 0. Some people also call these bounce points. That's it.